Welcome everyone for today's webinar on the topic of maturing your cloud. Our speaker today is Ben Goodman, who is the founder and CEO of DragonDrop.cloud, as well as the maintainer of a Cloud Concierge open source tool, which delivers Terraform best practices and pull requests. Prior to DragonDrop Cloud, Ben has also worked as a senior data scientist at Cloud Foundry. So he's going to help us and drive the session for today. Our goal is to really be for the next hour or so. We're going to talk about in kind of various formats and more of the stability of the cloud, how to mature your cloud using specifically Terraform and GitOps workflows. In the end, we'll be also talking about from our sponsor, CloudOpty, who is bringing the presentation today and organizing this event, is a cloud optimization certification and free training. So I'll take a couple of minutes to really talk about one slide about CloudOpty and then pass it over to you, Ben. So CloudOpty is a specialized SaaS platform for cloud optimization. It has a very unique solution of cloud scores, which is similar to your credit scores, what you have in the financial world. So there is a similarity which is being drawn in CloudOpty to have an indicator of how mature, how well established your cloud is. And with that indicator, as you continue to improve, we consider as 4 pillars of cloud optimization, whether it is on the cost side, the performance, security, or compliance. All the 4 different pillars which you continue to improve, and automatically your cloud score increase. It's a SaaS platform available. There is always a free tier which is available, no credit card required, and that free tier will continue to remain. One thing, it is available for AWS and GCP, 2 of the main public clouds, not yet for Azure, but the other 2. And we'll share about some training which is provided. You can have these links, all these things will be posted in the chat in a little bit. We have a free training for cloud optimization, and you can even get a certification after that. It's a growing area of cloud is becoming more and more prominent as well as complex. So having skills in that area is definitely a valuable skill. So that's the point, and some free resources. But without further ado, I would want to bring in Ben, and the floor is yours, Ben.
Okay, thanks for the introduction, Raju. Happy to be here talking about maturing your cloud posture. So with that in mind, I'll share my screen here. All right, so yeah, today we're going to be talking about maturing your cloud posture with Terraform and a GitOps workflow. So specifically, let's kind of go through a brief overview of the agenda, what we're aiming to cover today. First, we need a common operating definition of what cloud maturity is. We're going to take a bird's eye view of infrastructure as code and Terraform. We're going to define GitOps. So again, getting a standard definition there. We're going to discuss why using Terraform within a GitOps workflow is so valuable. We're going to talk about some tools that exist for building upon Terraform's declarative syntax and nature, specifically around cost estimation and security scanning. And then we're also going to talk about, we have this great setup with Terraform and GitOps, but what are some roadblocks to success? What would prevent us from using this great setup and achieving a level of cloud maturity that we desire? So specifically things like Terraform drift and resources that are not yet managed by Terraform are potential roadblocks we'll discuss, as well as some potential solutions. So yeah, let's get a definition that we can, collectively have for cloud maturity. Essentially, we're going to say cloud maturity for the purposes of this talk is the ability of an organization to quickly, cost-effectively, and securely deploy the cloud infrastructure needed to support business requirements. So quickly, click something wrong there. Cost-effectively and securely. Now, what is infrastructure as code? before we get into what infrastructure as code directly is, we should think about what existed prior to infrastructure as code for managing our cloud environment. So previously, this is just one example, but a common approach was to use a command line interface tool like the AWS CLI to manage, create, update, and delete cloud resources. So here we have an example of someone manually creating a S3 bucket using the AWS CLI. Another common approach is simply, logging into the Cloud Console, navigating through the user interface, and defining resources this way. So clicking through, saying, hey, I want the bucket to have this name, I want to have ACLs disabled or enabled, etc. What are some, challenging situations that arise from these approaches that were the dominant forms of managing a cloud environment prior to infrastructure as code? So the first one we'll call the fat finger, configuration error. Say you have a naming convention for your cloud resources, or some other configuration requirements. Someone goes through, they accidentally click or type in a way that is not aligned with those policies, and then you have an error, even though no one intends to have an error out of compliance with their organization's cloud policies. Another big problem that arises is when trying to share and replicate resources across an environment. So as an example, maybe you have a distributed organization with different teams consuming different cloud resources. Say, hey, that server that you configured for your project, our team also needs a server. How can I make sure that I have a similar server definition for my team's environment? And when the way that server was initially created was someone clicking through a user interface, generally a very complicated user interface, several months ago, that's a very hard question to answer, right? So oftentimes it's like, follow best practices and hopefully you get it right. Similarly, if you want to go from, say, hey, I have this server in my development environment, it works really well. Now I want to use it in production. This also becomes a painful process. And lastly, but certainly not least, if you have a infrastructure change that leads to challenges in your production environment, this can be complicated to resolve quickly if you're using something like the AWS console or, say, the Google Cloud CLI to make your changes, because you don't have a clear record of what the change was or the state of that infrastructure was previously. So answering the question, hey, can you roll back to exactly what we had before this piece of infrastructure crashed, is not easy. And that's not a comfortable situation for us as infrastructure managers when production goes down. Okay, so why infrastructure as code? Essentially, infrastructure as code is representing cloud infrastructure through written code configuration. So this enables us to manage cloud infrastructure through a version control system, just like any other code that we generally build applications with. This means you get all the advantages of something like Git. It's easy to roll back to previous versions. We have written records when changes are made. You can see who made the changes. The other nice thing this gives us is it allows us to make templates and share kind of best practice infrastructure configuration, both throughout an organization and across environments. So this is the idea of, hey, this database setup works really well. We've written it up as infrastructure as code. You can just use this database definition and know that you're going to get exactly the same features that we're enjoying right now. So why Terraform? Terraform is one of several infrastructure as code tools out there. Terraform happens to be the most popular, largely because it was early, and it was early to support multiple cloud providers. So you can use Terraform to manage AWS, Azure, Google Cloud. You can also use it to manage other third-party tools like Datadog, Databricks, DigitalOcean. So it has a really broad support. It's fully declarative, which we'll touch on a few times throughout this talk, but essentially it is declarative in the sense that what you write for a resources definition in Terraform, a cloud resources definition in Terraform, once Terraform runs and configures that resource, it will look in the cloud exactly as defined in Terraform. There's no hidden syntax. What you define in Terraform is what is created in your cloud. So this is, in opposition to something more imperative, where the classic example is, okay, go create this using the console. You'd say, hey, click on this tab, this button, then navigate to the next tab and click on this button. It's very instruction-based. With Terraform, it's here's what I want my database to look like, and then Terraform abstracts away the rest. Terraform also has a great, what's called a plan and apply workflow. And what this is essentially allows you to plan and preview the changes that your newly written Terraform will make to your remote cloud environment. And then once you're satisfied, apply those changes. And yeah, this last bullet point basically just double clicks on this idea of the community is really, really large with Terraform. So there's over 15,000 modules, which is essentially, for those that are unfamiliar, a packaged up collection of Terraform defined cloud infrastructure. And you also have over 3,500 different providers, and a provider is a plugin to the Terraform base package, which allows Terraform to manage an external API. So as an example, there's an AWS provider, there's a Google Cloud provider. Community members have made providers for things like Spotify, so you can create a Spotify playlist declaratively using Terraform, etc. And then, of course, of which this talk is merely an example, there's tons of learning resources and content because this community and user base is so large. Okay, so we've gone through what infrastructure as code is, why we want to use it, why Terraform is kind of the apex infrastructure as code tool at this point in time. Now let's kind of get a definition for GitOps. So GitOps is essentially when we use Git repositories as a source of truth for managing operational tasks and primarily cloud infrastructure. And you may have realized this as we went through that definition, but essentially managing cloud infrastructure within a Git repository is pretty explicitly enabled by having a tool like infrastructure as code available, since we need some form of code to work within our Git repository. So what's really cool about combining Terraform and GitOps is that Terraform, as I previously touched on, is declaratively defined. And because it's declaratively defined, we can perform static analysis on our Terraform code and essentially, within a GitOps CI/CD pipeline, test and assess our cloud infrastructure as defined by Terraform before it actually gets deployed. Looks like I jumped ahead for this bullet point. And then, essentially, this array of tools that the community has created, both for static analysis as well as deploying Terraform, is really powerful and really helps us quickly add a lot of maturity to our cloud management posture. Okay, so let's kind of double click on the 3 points mentioned in the previous slide and go through how we kind of need all 3 to get the full value here, and that 2 on their own kind of leave us wanting. So if we just have a declarative infrastructure as code tool and we have CI/CD pipelines, that's great. We'll probably get really fast deployments of our cloud infrastructure. That's cool. Usually, fast deployments of cloud infrastructure in and of itself isn't the end goal, right? Yes, we do want fast, but we don't want fast and insecure or fast and super expensive, right? On the other combination, we have, really good, say, community tooling, or we have a large community tooling developer base, and then we have our CI/CD pipelines. But if our infrastructure as code is not declarative, we'll probably get less effective tooling, simply because it's harder to analyze and assess the final outcome created by more imperatively written commands to define our cloud infrastructure. For the final combination, we see, we have community tooling that can be built upon declarative infrastructure as code, but without the automation provided by a continuous integration or continuous deployment pipeline, we have really manual processes for getting value out of these community tools, essentially. So we combine all three, we get into a happy smiling face at the intersection. Awesome. So let's kind of walk through a few community tools that are pretty valuable, and I'd recommend looking into if you're building your Terraform workflow. And I myself and our company have no affiliation with these tools. So yeah, we just think they're pretty cool, and it's worth knowing about them. So yeah, let's talk about how we can add cost estimations to Terraform. So there's this great tool called InfraCost. It's open source. You can run it on the command line, and essentially it will scan the cloud infrastructure you have defined in Terraform and estimate costs based off that definition. So you can imagine, because everything's defined declaratively in Terraform, we can see very explicitly, say, the instance size of a database, the amount of storage attached to it, the number of IOPS we need supported in that database. And so InfraCost applies the rules to translate those characteristics to an estimated monthly cost. And what's really great about this is when we create new Terraform, we can run InfraCost against it and see within our CI pipeline, within our Git repository, what our costs are expected to be or how they're expected to change prior to deploying those cloud resources. So they even have a Visual Studio plugin. So as you write Terraform here, we see this example for an AWS EC2 instance written with Terraform. We can see the total monthly cost estimate that that InfraCost is providing directly above the resource definition. So here, that instance type is quite large. Maybe we want to reduce that and reduce our expected monthly costs after we deploy this resource. Cool. So we talked about cost estimations, proactive, built around our use of Terraform. The other thing we can do is there are several tools out there that will enable enhanced security scanning of Terraform. So they're all essentially similar in how you use them and how they're output. They're CLI tools. You point them to a Terraform directory, and then they identify common security misconfigurations. So we have checkoff, we have Terrascan, and TFSec, which is now incorporated into a tool called Trivy. But essentially, the flow is very similar. You can run in a CI pipeline, say, hey, run checkoff against my Terraform, and checkoff will say, hey, maybe this service should only accept HTTPS traffic instead of allowing HTTP traffic as it currently does. Awesome. So we have our GitOps workflow. We're running security and cloud cost estimations against our Terraform prior to merging it in. And once we do merge it in, we're deploying it programmatically. We have smooth, fast, secure deployments of cloud infrastructure using Terraform. Awesome. We have solved everything. Okay, so yes, in the ideal state we have, but there are some roadblocks to success, which definitely are worth digging into and being aware of as you advance on your cloud maturity journey here. So the primary roadblock to success that we see are when changes are made outside of Terraform, right? Because if changes are made through that Terraform workflow we just described, it's likely good things are going to be happening, but we lose all those advantages when that workflow is not used. So just to review, the typical Terraform workflow is essentially you write your Terraform definitions, you have an infrastructure deployment process, and that process updates both your cloud and takes a snapshot of your cloud after post update and stores it in what's called Terraform state file. Now, what can happen is there are several ways that someone can go into a cloud environment and make changes. Someone can go into the Google Cloud console or the AWS console and touch cloud resources. They can use the CLI and make changes. Perhaps you have an application or deployment pipeline that has the credentials and is itself making changes to your cloud environment. And so now what has happened is changes in resource have occurred, and now new resources exist in your cloud that have not gone through a Terraform-based deployment process and are potentially susceptible to the cost and security vulnerabilities that we hope to avoid in the first place by implementing such a pipeline. So that's the setup of the problem. What are some approaches that we can take to resolve these roadblocks? So there are a few strategies native to Terraform. One is essentially make sure that what we saw in this previous slide, none of these avenues for changes outside of Terraform have any permissions to make those changes. So essentially lock down your cloud environment, only give write credentials to Terraform in your Terraform pipeline, and voila, we've solved the problem. Of course, this is really challenging for organizations that are new to Terraform. If you're adopting Terraform, it can be a bit of a culture change, and there is some upskilling that's needed. And to go from people clicking through the cloud console constantly to none of that can be perhaps disruptive. The other thing too is that this can limit our ability to respond really quickly. If something, say, breaks in production, we need to make a quick fix and click through the console one time. The other thing we can do is we can regularly run Terraform plan and identify drift. Drift being the idea that the resources defined in our cloud environment have moved away, have drifted away from what we have defined through our Terraform configuration. So when we run Terraform plan, Terraform will actually preview the changes that need to occur. And if drift has occurred, we'll see changes that we did not anticipate being there, existing within our Terraform plan output. So we'll see, hey, Terraform is anticipating changing the definition of this AWS Lambda function because what we previously deployed using our existing Lambda function has now drifted away from what's actually in our cloud, and we need to revert those changes the next time we run Terraform apply. So this is one strategy. Unfortunately, it's blind to resources that are outside of Terraform control, right? So what does this mean? It means if you have a resource in your cloud that was created by any mechanism that is not a Terraform deployment, then Terraform plan will not be able to identify or even know that that resource exists. The other piece is that the output of Terraform plan is a bit cumbersome. If you want to work with in an automated fashion, especially if you're running Terraform plan automatically, you probably need some kind of custom parsing of a Terraform plan output. Okay, so what's another strategy for kind of resolving some of these roadblocks? Recently in Terraform 1.5, the team behind Terraform introduced an import block that allows you to quite easily bring a resource that is not controlled by Terraform under Terraform control. So you can write this import block, automatically generate the corresponding cloud, automatically represent the Terraform representation of the cloud, of your cloud resources using this command, Terraform plan, generate config out. And then the next time you run Terraform apply, Terraform will actually update itself to begin controlling resources in your cloud environment not previously controlled by Terraform. So this is all great. The tricky part is, though, is actually creating that initial import block in the first place is, still a pretty manual process. You have to identify the uncontrolled resource, and then you have to write a import block with a particular syntax prior to running the subsequent steps. So yeah, we've gone through some native strategies, and then, our organization, Drag and Drop, we're pretty preoccupied with some of these challenges. And so we've actually developed our own open source tool that will automatically identify and codify those resources that exist outside of Terraform control. This tool, Cloud Concierge, also detects drift when it occurs proactively. So you don't need to run Terraform plan. Tool will simply scan your cloud, compare it against what Terraform thinks the state of your cloud is, and output a difference. The tool will also, identify who and what entities are actually making changes to your cloud environment outside of Terraform. So, not only has drift occurred, but who caused the drift in the first place, who created that S3 bucket outside of our Terraform workflow. So that way your organization can, throttle down potentially those cloud permissions and really work to move everything through a GitOps workflow. We also natively include and embed outputs from some of those community tools we mentioned previously. So instead of configuring for yourself, cost estimation and security scans, it all comes into one place, one output format within Cloud Concierge. And everything is output from an execution of the Cloud Concierge container into a pull request within your version control system. So really sticking to the ethos of infrastructure as code belongs in a GitOps workflow there. Okay, so this basically takes me to the end of the prepared remarks, just to, touch on the three main themes here again. One, we want cloud maturity. We want to be able to manage cloud infrastructure quickly, securely, and in a cost-effective manner. The one such approach that enables this in a pretty effective way is essentially using Terraform, a declarative infrastructure as code tool, in combination with community tools run through GitOps workflow. And yep, spent a lot of time going over that. And the last thing is just to be aware of how changes to your cloud outside of Terraform in a GitOps workflow can reduce the benefits described by this identified solution. All right, so that's it for the prepared remarks. Happy to answer any questions folks may have about anything I had gone over, or Terraform best practices. Yeah.
Thank you, Ben. Thank you for the informative talk and describing and wonderful work you're doing with the open source. That's amazing too. Yeah, team, I think we can open up for Q&A, and then I've posted a few links in the chat, but we would love to go through them and point you to the next webinars and things like that. But let's give a Or let me, while people are preparing for questions, some may not have questions, may want to drop off, but in interest of time, first, maybe let me just go through those links, what I've shared, and next steps possibly, and then accordingly we can build onto it. So we try to typically do at least one webinar per month, and there are various meetup groups which we have, and then I've shared this particular link, which has all this meetup links which you can join as per your interest. There is one with the big data and AI. There is a couple of Google developer groups. These are official Google developer groups which we have. So those are there, like Microsoft Azure related groups, and they are somewhat affiliated to Google and Microsoft, but not officially by Google, but it's a official Google developer group. And there are some other technical programming and things like that. So whichever is of your interest, you can join. And then we try to host at least one per month or more than that. And the next one, which is coming up, is on 6th of November, pretty soon, on data visualizations and basics of data visualization. So that's going to be a topic which we're going to cover. It's a very popular topic and a lot of interesting things to be covered there as well. As Ben talked about, I think cloud is definitely growing and expanding and becoming more and more complex. The cloud providers, whether it's Google, whether it is Amazon or Microsoft, they provide us a lot of tools to fix it, but I think it's not necessarily all the solutions which are provided by the cloud providers. So that's why tools like what Ben talked about, whether it is native tool or open source tool, and amazing work and by that. We also talked about, like the other links which I shared. There's another platform which we have built, and CloudOpty is one of the sponsors for today's event. And you have a free training for cloud optimization, and just to get some skills on that and a certification after that. It's a small training and certification. I think, as I said, cloud optimization is definitely a growing area of skill, and as cloud continues to grow and becomes more and complex, I potentially even think like there could be a role called cloud optimizer, like cloud engineer and all of that. This is possible. So feel free to use that link and join that. And another tool, which is CloudOpty, it's a SaaS-based platform which provides cloud optimization and a CloudScore, a unique solution as we talked about. So feel free to register for that as a free tier, and it's going to be always remaining as a free tier. So just wanted to share those resources and next steps if somebody wanted to leverage that. And with that, we'll come to the end of the prepared content, but open to any kind of questions and formats anybody has. Yeah. So with that, we'll end the session. Thank you for joining, and hope to see you in the future webinars or meetups. And feel free to connect with Ben or log into CloudOpty or dragonsoft.cloud. And thank you very much for the session. Have a good rest of the day. Thank you very much.